Hello students, as we are seeing important questions based on competitive exams. Today's important questions from electron gain enthalpy. Actually, today I would like to give some important tricks, tips, informative points I would like to give you all. See, mainly if you know the tricks and tips and information, easily you can identify the answer and confidently also. Yes, that's what I would like to give you. Yes, come on. The first one, the importance of electron gain enthalpy is also known as electron affinity. Electron gain enthalpy is also known as electron affinity. That electron affinity or electron gain enthalpy, the elements are having high electronegativity values of electron gain enthalpy are capable of accepting electrons. So, capable of accepting electrons means these elements are electronegative in nature. So, that is the first point. So, which is having electronegative in nature means which is easy to accept the electron. So, which will be easy to accept the electrons? Which one we are having high electronegative values of electron gain enthalpies? Yes. The second point says the elements are having high electronegative values of electron gain enthalpies acts as a strong oxidizing agent. Please note the point. So the electron gain enthalpies, which will be electron gain enthalpies which is having a high electronegative values, they are having what it is, electron gain enthalpies, that is acts as a strong oxidizing agent. So, what are the strong oxidizing agents? Example: fluorine, chlorine, bromine, oxygen, sulfur, and etc. Whichever is having electronegative values very higher, that is belongs to electron gain enthalpies. They are strong oxidizing in nature. Okay, now the next one, on the basis of ionization enthalpy and electron gain enthalpy. See the difference: ionization enthalpy and electron gain enthalpy. Metallic nature, non-metallic nature. How do we identify in the groups and periods? You know very well groups and periods in that way. So metallic nature decrease in period while non-metallic nature increase in period. See, now as you see the periodic table, this is a group. Okay. So in that way, the arrow mark shows the metallic nature, electropositive in nature, metallic nature, it is decrease in period, whereas increase in groups. The arrow mark goes upwards. So I just put it in that way. So arrow mark upwards, metallic nature, increase in group, whereas decrease in period, metallic nature, it is decrease in period. Yes, fine. Now the next one, metallic nature increase in group while non-metallic nature decrease in period. The same way, non-metallic nature, you see this diagram, you will come to know very clearly. So in this diagram, what it has mentioned, non-metallic, as it is goes in the period, it is increasing, but in the group it is decreasing. So as you see that groups and periods in the periodic table, so this is groups and this is period. So that is what I put it in that way, arrow mark. So in that non-metallic nature, in the period it is increasing, but in the group it is decreasing. But metallic nature, in that period it is decreasing, but in the group it is increasing. So metallic nature and non-metallic nature, as we have seen. Now in next point we are going to see the reducing agents and oxidizing agents. Electron gain enthalpy plays a very big role in the periodic table. So, in that, reducing in nature, oxidizing in nature, stability of metal, activity of metal, basic nature of oxides, acidic in nature, all these, whether it is increasing or decreasing among the group and period. So, in that way, we can recognize very easily, clearly way I have given a tips for you. So, reducing in nature, in the period, arrow mark goes straight. Increase means go upward, decrease means comes down, like that I just mentioned. So cleanly you can see to that. So reducing in nature, that reducing in nature, electron gain enthalpy, that is decrease in period and increase in groups. Please note that reducing in nature of electron gain enthalpy, decrease in periods and increase in groups. The same way oxidizing in nature end period, it is increase in period and decrease in group. See that aroma, it is decrease in group. The same way stability of metal, it is increase in period and a decrease in groups. The same way activity of metal, that means it is what it is, a reacting way. So activity of metal, that is decrease in period, increase in group. And the same way basic nature of oxides, increase in groups and decrease in periods. The last one, acidic in nature, it is increase in period and decrease in group. As you see this, you will come to know the clarity. Please take that screenshot so that it will be easy to identify periods and groups. You will come to know very clearly. Okay, now let us go for some more important questions. Some more important points to remember series. Chlorine has highest electron gain enthalpy. Successive electron gain enthalpies are always positive. Electron gain enthalpies follows a trend. Halogen group is greater than oxygen group, is greater than carbon family, it's greater than nitrogen family, it's greater than metals of group 1 and 13. Metals of group 1 and 13 and metals of second group and zero group. So this is actually electron gain enthalpy. Next one, sequence of electron gain enthalpy of second group. So what is the sequence you can follow? Beryllium is lesser than nitrogen, is lesser than lithium, it's lesser than boron, it's lesser than carbon, it's lesser than oxygen, and finally fluorine. Okay, now the sequence of electron gain enthalpy of third group. This is the second group, third group. Magnesium is lesser than sodium, it's lesser than aluminium, it's lesser than phosphorus, it's lesser than silicon, and it's lesser than sulfur, and it's lesser than halogen. So chlorine, fluorine, bromine, iodine, I think you halogen group. You got an idea as you see the sequence. And finally, some of that exceptional, no, see what is the reason for it. Electron gain enthalpy of some of the elements of second period, nitrogen, oxygen, fluorine, lower than corresponding elements, that is phosphorus, sulfur, chlorine, of the third period. This is due to smaller in size and electron repulsion. So these are the main points to remember for that to identify the correct answers. Please take down that screenshot so that it will be helpful to crack out that answers clearly. Now, we are going to see some important facts about elements. Information as a resource, information is a knowledge. Actually, information nowadays, it's a power that is mainly important in inorganic chemistry. Okay, now the first one, tungsten has the highest melting point among metals. How much it is? 3380 degrees Celsius. Carbon has the highest melting point among non-metals, 4100 degrees Celsius. And lithium has the lightest metal density, it is 0.54 gram centimeter minus 3. Boron has the lowest atomic volume, and helium has the maximum ionization enthalpy, and cesium or francium has the lowest ionization enthalpy. You know which is the highest ionization enthalpy, lowest ionization enthalpy. As you see the ionization enthalpy word only, you will come to know which is highest and lowest. Yes. Element kept in water. Which element has kept it in water? Phosphorus. Which element it kept in under the kerosene? You know very well. Which one? It's a sodium. Okay, hydrogen is the most abundant element in universe. Note that. Hydrogen is the most abundant element. Generally abundant element. Aluminium we can say, oxygen we can say, iron we can say. But abundant element in the universe, it is hydrogen. And ozone, usually gas, it won't be colored, but ozone, it's a color, and ozone colored gas. And what smell? It is garlic smell. Okay, most poisonous metal, plutonium, it's a poisonous metal. Maximum number of isotopes, which is the maximum number of isotopes in that element standard, that is 10 isotopes. You know which planet is having more natural satellites? You know, Jupiter, it is 16 natural satellites. The same way, Earth only one, that is Moon. You know, like that, important names of that, all those information, it's very very important. Okay, now maximum number of isotopes, it is standard, that is 10 isotopes. Least conductor among metals, it is plumbum, lead, Pb. Number of gaseous elements in the periodic table. Number of gaseous elements in among the periodic table. How many? 12 gaseous elements present in the periodic table. So what are they? Hydrogen, helium, nitrogen, oxygen, fluorine, chlorine, neon, argon, krypton, radon, and oganesson. OG. It's new one, right? 118, the atomic number it is 118. OG, oganesson. Okay, now special names of that group. Special names of the groups and periods in the periodic table. Okay, group 1, that is 1A also we can say. Group 1, alkali metals. Group 2, alkaline earth metals, that is S block elements, you know very well, right? Now the next one, Group 15, Nectogen, nitrogen family. Group 16, Chalcogen. And Group 17, Halogen, you know very well. Group 18, inert gas or noble gas or zero group element, you know very well. I hope you got a clear idea about all these informations, because information, it's a knowledge and power resource, and it's very very important for inorganic chemistry. Generally memory based type questions, you may get it from inorganic. So logical way thinking, memory based. So please go through all these points. If you want, you can take that screenshot. Now let us start the competitive based questions. Electron affinity depends on atomic size, nuclear charge, atomic number, both A and B. By this time you will come to know the answer, because you just now you have gone through that affinity, electron gain enthalpy, all the informations we have gone through. Okay, now what is the answer? Answer, it is option D. That is both A and B. What are those? Atomic size and nuclear charge. So electron affinity depends on atomic size and nuclear charge. The next one, ionic radius. So ionic radius, how to calculate? So ionic radius is inversely proportional to the square root of effective nuclear charge, that is ENC. I have written effective nuclear charge. Ionic radius is directly proportional to effective nuclear charge. Ionic radius is square directly proportional to the square root of effective nuclear charge. The last one, ionic radius, is inversely proportional to the effective nuclear charge. So our option, correct option will be where? Which is that? D option. Why? Because ionic radius is always inversely proportional to the effective nuclear charge. That is only the correct option. Hope you got a clear idea. Wait, some more important questions let us go through. And these two questions are comes from AIDS. Okay, come on, let us go for some more important questions. The next one more important question, but it is very easy. The long form of periodic table consists of 8 horizontal and 7 vertical, 7 horizontal and 18 vertical, 7 horizontal and 7 vertical, 8 horizontal and 8 vertical. So as you see the periodic table only, you will come to know which is the correct option, and it's very important also. See, this side it is a period and down it is a group. You know, vertical it is a group. This is an horizontal, it is a period. So how many periods are there? This is you have learned from smaller classes onwards, right? So this is the period, how many periods are there, and this is the group, how many groups are there. See, here it has written 18, so 18 groups are there, and here it has written 7 periods are there. Which is the correct option? Option B is the correct option. 7 horizontal and 18 vertical. Hope you got a clear idea. So better daily you just to watch the periodic table, so you will come to know the all the answer. The next important question is ionization energy of hydrogen is much higher than that of chlorine, slightly higher than that of chlorine, smaller than that of chlorine, equal to that of chlorine. See, generally, hydrogen is more electronegative. So, in this point, option A much higher than that of chlorine. Why? Because hydrogen is more electronegative than chlorine. So, which is the correct option you can provide? Option A, much higher than that of chlorine. Now, for example, here sodium. Sodium is less electronegative, whereas hydrogen is more electronegative than chlorine. Okay, now next question. Which of the following has highest electron affinity? So, naturally here, nitrogen, chlorine, oxygen, fluorine. Chlorine is the highest electron affinity. Hope you got a clear idea. Okay, now ionization energy of nitrogen is greater than oxygen. Ionization energy of nitrogen is greater than oxygen. Why? Due to what it is? Half filled 2p subshell, less electropositive in nature, more electropositive in nature, none of the above. See, nitrogen 1s2, 2s2, 2p3, right? Half filled. So naturally, option A will be coming. So this is half filled 2p subshell. Okay, I hope you got a clear idea of these questions, and these also it's very important. Come on, let us go some more important questions. The next important question, which of the following sets of ions represents the collection of isoelectronic species? You know isoelectronic species very well. Option A, K plus, Cl minus, Mg2 plus and Sc3 plus. Right? Okay, now Na plus, Ca2 plus, Se3 plus and F minus. And C, option C, K plus, Ca2 plus, Ac3 plus and Cl minus. And the last one, Na plus, Mg2 plus, Al3 plus and Cl minus. Already I have given the idea about isoelectronic species. Atoms or ions are having same number of electrons. That is called isoelectronic species. In this, option C, it will be correct. You know why? Because K plus. K plus is how many electrons? Plus means what it is? Losing one electron. Minus means gaining one electrons. You know very well. So here K plus, it is actually potassium 19 atomic number. But here K plus 18 electrons. And then Ca2 plus. Here also 18 atomic number 20. So 2 plus, that means 2 electrons it has contributed. And then Sc3 plus, here also 18 electrons, 21 in the 3 electrons contributed. And Cl minus, of course, minus it has mentioned. So that means what it is? Gaining 1 electron. 17 plus 1, 18. So all these are having 18 electrons. Same number of electrons. Atoms or ions are having a same number of electrons, which is called isoelectronic species. Hope you got a clear idea. You know which is the correct option? C is the correct option. Okay, now which of the following elements contain metalloid elements in the periodic table? So they have given the option sodium and potassium, fluorine and chlorine, calcium and magnesium, arsenic and silicon, and copper and Ag, silver. As you see, only you yourself will mark which is the correct option. A, S and Si, arsenic and silicon. The next one, atoms or ions that has highest number of unpaired electron. Atoms or ions which has highest number of unpaired electron, let us find out. So this is Na plus, so 1 electron it has lost. That means 1s2, 2s2, 2p6, right? So that means there is no unpaired electron. Here fluorine 1s2, 2s2, 2p 5, 9 electrons, right? So that means here only one unpaired electron, right? Now this is nitrogen 1s2, 2s2, 2p3, and oxygen 2 electrons it has gained 1s2, 2s2 2p6. Actually 8 only, 2 electrons which is gained, so that means this is, so here also no unpaired electron, the first one also there is no unpaired electron, and fluorine only one unpaired electron, and nitrogen which has 3 unpaired electron, 3 unpaired electrons. So which is the highest unpaired electron? Nitrogen is the correct option. Okay, the next one, among the electron, magnesium Mg2 plus Mg, Mg2 plus Al, Al3 plus, which will have the largest and smallest size respectively. So as you see that options, Mg, Al3 plus, Al3 plus Mg, Mg2 plus Al, and Al Mg2 plus. Right. Okay. Now, as you see, I would like to tell one word here. Cations will be always smaller than the parent atom, because cations, it is contributed electrons. That is what plus ion you are getting. Okay. Now, here in this point, which is largest and smallest size. So, cations will be smaller than the atom of that main. Okay. Now the second point, generally from left to right, ionic and atomic size, it will be decreasing as it is going to the period from left to right, ionic and atomic size, it will be decreasing. So which option will be the correct? So magnesium and Al3 plus. So from here, this is magnesium and Al3 plus, which is decreasing. Largest and smallest option will be, what is it? Option A is the correct option. I hope you got a clear idea about this point. Okay, now the next one. The correct arrangement of their ions in the increasing order of their radii. So, increasing order of the radii means what it is? Na plus, Cl plus, Ca2 plus, and the B option Ca2 plus, K plus, S2 minus. The third option Na plus, Al3 plus, and beryllium 2 plus, and the fourth option Cl minus, F minus, S2 minus. In the question, it has mentioned ions in the increasing order of their radii. So, isoelectronic species they have given. In this, atomic number decrease, radii will be increasing. Okay, in that way we can find the option B. So in this way, option calcium, it is atomic number 20, this is 19, and sulfur 16. So atomic number decreasing, whereas ionic, what it is, radii, atomic radii, which is increasing. So in this way we can opt this option. Okay, I hope you got a clear idea about all these questions, whatever we have gone through. Just go through thoroughly. Thank you for watching.